those three, start off with a continuation of airspace. All right, we're gonna go through a little bit of weather theory, and then we're gonna end it with some weather reports and forecasts. All right, just like most days, I'm gonna give you guys 2 breaks today, one 10-minute break, one 5-minute break. You guys are gonna choose which one's first, which one's second. So start getting your choices in now. All righty. Let's see. Airspace part 2. Let's get that sign-in link in the chat. Make sure I'm sending it to everyone. Bam, sign-in link is in. Cool, cool, cool. Awesome, still coming through. All right. Per usual, guys, if you guys need the sign-in link one more time, let me know within the first 5 minutes of class, and we'll be good to go. So then you another link. All right, let's get into airspace part 2. Yesterday, we really went over like the big ones, Alpha, Bravo, Charlie, Delta, Echo, Golf, right? We hit it hard. Now we're gonna go into some special use airspace. Now, we have yet another acronym that you guys need to write down, okay? MCPRON, okay? MCPRON. This is for your special use airspace. Okay, so MCPRON is comprised of military operations area. We know them as MOAs. All right, controlled firing areas, prohibited areas, restricted areas, alert areas, warning areas, and national security areas. All areas. All right, give them a few more minutes to write it down. All right. Let's continue because we're going to go through each one of these one at a time. So let's start with those MOAs, the military operations area. Okay, so they are, and this is a direct quote from the FAA, they are established for the purpose of separating certain military training activities from IFR traffic. All right, to separate military training activities from IFR traffic. That was what they were originally built for. So what does that mean for VFR? Well, you can fly right through if you're VFR. But another direct quote from the FAA coming at you. Pilots under VFR should exercise extreme caution while flying within a MOA. All right, exercise extreme caution. So you are still allowed to enter VFR, but it's not exactly recommended. So what you can do is you can contact a flight service station before you get to the MOA if you're planning on flying through it, and you can get accurate real-time information concerning the MOA's hours of operation. So you can find out, hey, are they currently using it or not? Questions on MOAs? Alexander.
I just want to make sure I got this right. So instrument you can't go in, but VFR you can, but you just have to be exercise extreme caution. Is that correct?
Right. And these MOAs will have times like where they're like hot or cold. So even if you are currently on an instrument flight plan, if the MOA is cold at that moment, you would be able to go through. You just have to ask the controlling agency or just ask ATC.
Thank you.
All right, then we have controlled firing areas. Notice how there isn't a picture here. Well, that's for a reason. So controlled firing areas, potentially, they could pose a hazard to us. However, these are areas where they literally have, like they're setting off like gunnery, missiles, and testing them and things like that. And what they're gonna have on the ground are spotters. That means they have people looking at radar and literally someone out there with binoculars looking out for aircraft in the vicinity. This is one special use airspace you just don't need to worry about because it's not even going to be charted. You don't have to look for them because they are looking for you. Now, when you fly over a controlled firing area, they will cease all activity. So even if you just park right above them and start doing maneuvers for like an hour and a half, they will just sit there and wait for you because you didn't even know they were there in the first place. They stopped for you, okay? So the definition from the AIM for this airspace is airspace designated to contain activities that, if not conducted in a controlled environment, would be hazardous to non-participating aircrafts. So these areas are invisible. They're not charted. You're not going to see them because they stop for you. Question.
Can
Okay.
you repeat the FAA definition?
Airspace designated to contain activities that, if not conducted in a controlled environment, would be hazardous to non-participating aircraft. All right, now I'm going to start talking about these prohibited areas. All right. Prohibited areas are areas in which they have some very high security things. They're going to have things like the White House, Camp David, also including nuclear weapons facilities such as ballistic missile submarine bases in Georgia and in Washington. They also have a Pantex plant in Texas where they build warheads. These are prohibited areas. Now, prohibited areas, they do not have hot and cold times. Okay, they don't turn on and off. They are always on. Now, if you ask someone if you're able to go through a prohibited area, the textbook definition is that yes, I potentially could go through a prohibited area if I got permission from the controlling agency. However, are you going to get that permission? Absolutely not. 99.9 repeated percent of the time, that's going to tell you no, no flying in this prohibited area. So unless you're flying around the president, you're not going to get that permission. But you are able to ask, okay? So if you're being asked, it's like a trick question, are you able to go through a prohibited area? The answer is not just no, it's if I got permission from the controlling agency. Okay? Are we understood? Okay. Keith.
I'm guessing the only exception would be in case of emergency, say you lose an engine, that would probably be the only exception, am I correct?
That is always the exception. All right, now we have restricted areas, all right? So we're now going to the R of McPrawn, all right? So the quote from the FAA, restricted areas denote the existence of unusual, often invisible hazards to aircrafts. Some examples with this, if like you have fighter jets, like formation flying and doing maneuvers, that would be a MOA, right? Fighter jets just like flying around doing maneuvers, that'd be a MOA. However, if they're practicing aerial gunnery, that would be a restricted area. All right, so these are going to have hot and cold times. Restricted areas do have hot and cold times. Times are active, times that they're not. Now, if they are hot, if they are active, right, you wouldn't be able to go through, okay? If they are currently cold, awesome, you can totally go through. It doesn't matter if you're VFR or IFR, the rules are the same, okay? Now, when you could call the controlling agency to see if, like, if they would, if the area is hot or cold, they're not exactly gonna give you permission to go through if it's hot, but they're able to tell you, hey, it's hot or cold. Questions? Okay. Alert area. So, they do not give the definition here. That's okay. So the idea of an alert area is an area of usually high amount of training aircraft. All right, high amount of training aircraft. You're supposed to be especially alert in alert areas. There is no special permission needed to enter, right? There is no hot or cold. You can go through it anytime you want. It's just a caution that you guys need to be more alert because there's a lot of training aircrafts in that area. So there's a lot of aircraft doing maneuvers and things like that, things you wouldn't expect when you're just out flying to another location. Now, according to the AIM, they may use a common frequency for traffic advisories. This is not true of many alert areas, but a good majority use the frequency known as fingers, 123.45. 123.45. Many of them don't use that, but the majority use 123.45, known as the fingers frequency. Okay? If you're doing maneuvers in an area that's denoted as an alert area, it's usually quite common that people will, if I'm about to do steep turns, I would say Miami area, or Miami alert area, career track 223 at 2,500, 5 miles west of FXC doing steep turns. And that lets them know what altitude I'm at, my approximate location, and what maneuver I'm doing, so they know what to look for if they're gonna be flying by. Questions?
You would announce that on the fingers frequency.
On the fingers frequency, yes. All right, warning areas, all right? So once again, with warning areas, it's not that you cannot fly through them, but it's another one that uses those words, exercise extreme caution, all right? This is another one where it says, it doesn't say you can't, it says exercise extreme caution. There could be a lot of military activity and training. You're gonna see most of these off the coastline, okay? They may have the same sort of dangerous activities as a restricted area. Now, it's more than 3 nautical miles offshore, so the US government always doesn't have sole jurisdiction as well. They can't legally force you to stay out, but it's usually a good idea. So one of our designated pilot examiners down in Fort Lauderdale, he also works with the Air Force at the same time. So I asked him, hey, when you take those jets out in those warning areas, what are you actually doing? And he said the very last time he did something like that, there was a whole bunch of jets and they were basically playing tag with each other at very high speeds and shooting fake lasers at each other as like a training exercise. So when they're doing stuff like that, they're not paying attention to you and your little Piper Archie little Cessna trying to float through there like bump it up and up. Duh. They are going as fast as they can trying to chase each other and complete their exercise. NSA, okay, national security area. Now, usually there's going to be like an altitude restrictions that pilots are requested to fly above. That specific wording there, requested to fly above. But it's for the purpose of national security, so you should probably follow it. Now, Some examples is gonna be the Idaho National Library, the Ordnance Depot west of Provo, east of Pueblo, Colorado, and east of Livermore Airport. Okay, it is requested not to fly through these, and if we pilots respect that request, it's much more likely that they won't make this airspace something you're not able to fly through at all. So it is generally understood like around different pilots, like, hey, this NSA area, just don't actually fly lower than they request. Now, if there is ever a time for these NSA areas that they actually need you to not fly over it for like at any altitude, they can put in a temporary flight restriction, a TFR, okay? They can throw that up over the NSA area, so now it's like legit. It's not just a request anymore, now is actual law. That would be a temporary flight restriction. It could be up there for a week, a day, whatever they decide, whatever they need it for. But it's temporary though, so it should end. Questions? Okay. Now, we talked a lot about contacting the controlling agency. Well, how do you do that? Well, when you look at your sectional, on the back side, like on the other side of probably this page right here is like the legend that you can find in your sectional. Well, on the back side, down here especially, you're gonna see all these different agencies that you can contact. So let's say you're looking at this top one, right? It is prohibited area number 50. And if we go back to prohibited area, you can see is it will say prohibited P-204. So if that had said P50, we would say, oh, look, we found the number we're talking about, the P50. Altitude, 2 but not include 3,000. Awesome. Time of use, continuous, is a prohibited area, so it's never cold, just hot. And this one, ooh, they're not even giving it a controlling agency. My goodness. Now, same thing with restricted areas. It says R2903C. You see that on the sectional. You're gonna go over to the controlling, go back over here to the number to find the controlling agency. It will say the altitude, what times they are in use, and notice here it says Jacksonville TRACON. You're like, but there's no frequency. You can see at the very bottom here, they're all Jacksonville TRACON, so they only listed it once. This one can be a little bit harder. Do you have questions, Austin?
Is the altitude saying that if you're above that, you can fly over it?
Yes, up to but not including 3,000.
What about the what about the 7,000 to 7,000? You only fly up to 7,000, yes?
That's saying the restricted area starts to the surface all the way to 7,000. You'd have to overfly 7,000. All right, Austin, hand. Now, I want to take a whip out your phone and take a picture. These are the VFR weather minimums set in 91-155. Remember yesterday we were talking about special VFR and how if you couldn't get into an airspace if it was less than VFR weather minimums? These are those weather minimums. Now, many people, I like to memorize it this way, right? I like a nice chart. This made most sense to me. Kayla. Did anyone else not get that? Was it just me? I think she's good. All right, so yeah. So as you can see, we're gonna go through it really quick, and then I'm gonna show you the other way that people memorize it. This is the way I liked it. You had class alpha, the visibility. Remember we talked about class alpha? You need to be on an instrument flight plan anyways, and you need to be IFR. So there is no visibility, right? Distance from clouds, your instrument. You're literally designed to go through the clouds. All right. Class Bravo, you need 3 statute miles of visibility and be clear of clouds. Simple enough. Class Charlie, you need to have 3 statute miles. And we kind of memorize this by saying it's the 3 Cessnas, a 3, 1, 5, 2. All right, 152s is a very common Cessna. So it's 1,000 feet above, 500 feet below, and 2,000 feet to the side, horizontal. All right. So for class Charlie, Delta, and Echo, it's very common just to say it's a 3, 1, 5, 152. 3 statute miles of visibility, 1,000 feet above, 500 feet below, 2,000 feet horizontal. Now, it does mention class Echo with less than 10,000 versus at or above 10,000. Okay, so if you're at Echo at or above 10,000, you need 5 statute miles of visibility, and then it's 111. 1,000 feet below, 1,000 feet above, and 1 statute mile to the side. So above 10,000 is 5, 111. 5 statute miles of visibility, 1,000 feet above, 1,000 feet below, 1 mile to the side. Class Golf is where it starts getting a little tricky. All right, just take the most time to memorize because it has a lot of different scenarios. So, if you're less than 1,200 feet, remember we talked about most often, unless you see otherwise, Echo starts at 1,200. Okay, so if you're less than 1,200 during the day, all you need is that one statute mile of visibility and clear of clouds. Okay, 1 statute mile of visibility and clear of clouds. If you at 1,200 or less at night, then it goes back to the 3, 152. Okay, so if you're in classic golf during the day, it's just 1 statute mile of visibility and clear of clouds. If you're at classic golf at 1,200 and below during at night, it goes back to 3 statute miles, 152. Now, then you have another classification. If you're more than 1,200 AGL, but less than 10,000, then you have the day where it's 1 statute mile visibility, 152, but at night it still goes to 3 statute miles, 152. Lastly, if you're more than 1,200 and at or above 10,000 feet, where would that be? Either we see that blue vignette, or remember we talked about that zipper? That zipper can tell you where Echo starts. If it's over 10,000 MSL, you still get that 5 statute miles and 111. I know it's confusing. I know it's going to take a second to memorize. You just got to get it down in your notes so you can keep on going over it. Now, another way that other people like to memorize this is very common that a lot of people like to use this triangle. Take a picture, write it down, do what's best for you. So, Echo and Golf above 10,000 is the 5 statute miles, 111. All right, below 10,000, and take away the B here, the B does not belong here. Charlie Delta Echo is a 3 statute miles, 152. Anything Golf at night is going to be 3 statute miles, 152. Golf during the day, 152. 1,200, below 1,200 during the day is 1 statute mile, clear of clouds. The reason I say that Bravo doesn't belong here is because we all just saw on the last page, Bravo is, as you can see here, 3 statute miles clear of clouds. All right. Thank you, Damien. All right, now, oh, so sorry. Questions on VFR weather minimums? Okay. All right, special VFR. All right, so special VFR. We talked about this yesterday, but let's stop on it real quick. All right, so if you get to a airspace like where you're trying to land, and they do not have VFR weather minimums. Well, if they don't have their VFR weather minimums, technically if you're flying VFR, you wouldn't be able to land there because you couldn't keep your minimums. So what you can request is special VFR, okay? If you request special VFR, your minimums drop to, and they accept, of course. You request special VFR and they accept. They say, yes, you can fly under special VFR. Is 1 statute miles of visibility and be clear of clouds. That's it. 1 statute mile of visibility and clear of clouds. Now, you have to request it. They have to approve it. And then unless you're instrument rated and your aircraft is instrument rated, you could not request special VFR at night. Questions? All right, cool. Now, we're gonna start going through the others, right? The others. Now, these others, they're not technically classified as special use, but rest assured, they still special in their own special way. All right. So we're gonna talk about 3 more airspaces we're not considered special use airspace, but they're definitely worth knowing about. So first one we're gonna talk about is a TRSA. TRSA, TRSA, Terminal Radar Service Area. Now, the Terminal Radar Service Area is kind of like a relic from like a previous iteration of the National Airspace System. And it's basically a Delta, a Class Delta airspace that should probably actually be a Charlie. Okay, because it's busy enough to be a Charlie, but it's still designated as a Delta for some reason. Now, when you get to a TRSA, it is not mandatory whatsoever, okay? They're not mandatory, but you are able to contact approach on a frequency, and what they're gonna do is they're gonna give you traffic separation. They're gonna be able to get you into the closer to that Delta safely. Basically, what they can do is they're gonna make everyone get into a conga line all the way to the Delta. All right. So it's not just everyone coming from everywhere. They're gonna put everyone into a conga line to get all the way to the airport. So it's more safe that way. Okay. Now, it's voluntary. You do not need to contact these people. But is it smart too? Yeah, because it's a super busy Delta. Now, when you're coming in, let's say you didn't contact the approach frequency. Well, you would just contact tower just like you usually do, and they would get you in that way. It's just not as safe as it could be. Questions? All right. We talked about an ADIS yet. Oh, Joshua.
I did have one question, sorry, regarding the special VFR. Since it's 1 statute mile clear of clouds, is it basically like Class G under 12,000 AGL?
Is class golf under 1200 during the day, 1 statute miles clear of clouds?
Yeah.
Answered your question right there. All right. So the ADIS. All right. We talked about this yesterday, so I'm going to just take a quick look. All right. This is the Air Defense Identification Zone. Okay. Is a boundary of the National Airspace System. Okay. To fly in and out of the zone, you would need to be either on an instrument flight plan or a DVFR flight plan. What does that mean? Defense VFR flight plan. Okay. You must also possess your radio license, yourself, and your aircraft must also have its own radio license. Both you and the plane must have your separate licenses. All right. So, what does a lot of this mean to us as pilots? Well, quite usually, if you needed to, you could go outside that zone, no problem. It's coming back that could be a hazard to you. All right. They do give us the quote here. They give us 3 actually. ADIZs have been established to assist in early identification of aircraft in the vicinity of international US airspace boundaries. Cool. If penetrating an ADIZ, all aircraft must file, activate, and close a flight plan. The last quote is, in addition to normal ADIZ position reports, a foreign civil aircraft must give a position report at least 1 hour before ADIZ penetration. The more you know. Questions on an ADIZ? Damien.
What were the 2 licenses that you were required to have?
So it's called a radio license, but both you need it and your aircraft needs one. So they're both a radio license, but you would need one for you and you need one for your plane. All right, special conservation area. All right, so it is not special use airspace. It's not even like they're not able to enter, but it is highly requested that you do not fly below 2,000 AGL in and around these areas. All right, it's the sake of wildlife and preservation of the space. All right, landings should be prohibited. All right, exceptions, of course, emergencies, if there's a designated landing area or official government business. Questions? Damien.
Just to clarify, those numbers on the supplement chart are your elevation in MSL, right?
These, yes.
Okay.
Now, the CIFRA, all right? Special Flight Rules Area, CIFRA. Now, these can be in DC or the Grand Canyon, and then they are specific pieces of the airspace where you need to get special training or meet certain criteria before flying into them, all right? The DC CIFRA spawned out of that 9/11 terrorist attack, and this is a really good reason not to accidentally fly into this area. So technically, any special flight rules area is any area with special rules. Most often, the special rule is that you need to get extra training and get that license. Now, the one example that everyone likes to give is Washington, D.C. It is recommended that you get the training for the DC area if you're flying within 100 nautical miles. It's recommended if you're going to fly within 100 nautical miles, just get it, just in case. Training is required within 60 nautical miles of the DC VOR, and the training course is just on the AOPA website. Not too hard to get to, the AOPA website. Now, the actual flight restricted zone is kind of like the inner ring of the DC CIFRA. Now, other examples of areas with a CIFRA is the Hudson River area, as well as the Grand Canyon. Questions? All right, so TFRs, all right? We're using the acronym VANS, VANSS, VANS, okay? For the different types of TFRs, VANS. Now, these are temporary flight restrictions. Now, even though the word has the word temporary, a few of them are actually permanent, like the one over Disney World, all right? Either way, you're not allowed to fly into a TFR ever. Always check your NOTAMs before you go to fly. Your NOTAMs are where you're going to find your TFRs. For the people not writing that down, TFRs are listed in your NOTAMs. Write it down. Now, those temporary flight restrictions are to protect people from like you. Technically, when you start getting your pilot license, your name goes on a list as someone with access to a weapon of mass destruction. I heard that from a DPE once. I was like, oh, really? Me? Crazy. So all the information available in pre-flight actions. You can also learn about TFRs during your weather briefing, because in the weather briefing you get, they're going to list off all the NOTAMs. Okay, so let's go through the different types. We have VIPs like the president, vice president, probably Taylor Swift, those type of people, right? Then you also have air shows. When you fly near, Fort Lauderdale. In Fort Lauderdale, once a year, they do the Blue Angels show where they have a whole bunch of jets and they fly together like 1 inch away from each other. That's an air show. They don't want you ruining it for them, so they throw up a TFR. Then you have natural disaster areas. So after Katrina hit New Orleans, they had all these different like helicopters and rescue aircraft flying throughout the area, trying to do search and rescue, deliver water, food, the essentials. They don't want you and your little Piper Archer, your Cessna, getting in the way again. So you can have they put up a TFR for search and recovery efforts. Now, unless you contact the governing agency for the natural disaster, you can volunteer to be a part of the search and rescue, but unless you get that, just stay out of the TFR. Okay. Also, sporting events or other large gatherings. We talked about this the other day. If a stadium has an occupancy of 30,000 or more, they will throw up a TFR if it's going to be an event there. Okay. Lastly, space operations. So like Cape Canaveral, things like that. When NASA's shooting off a rocket, they want you out of the area. Questions? I know it's early and y'all are tired, but give me something. Someone asked me a question. Y'all are too quiet. Something's wrong. Keith, thank you.
What is the typical radius of TFRs, like space or sporting events?
So for like sporting events and all that, they're really usually not too big. Let me show you. You know my favorite site, SkyVector, when I'm teaching these classes. Bam. All right. All right. So this is. Ooh, this is TFR over all Washington, D.C. Interesting. But these are going to be your larger TFRs. This one is for VIP, the president and the vice president. This just says security from service to 18,000. Aha, this is the one for Disney World. And what's this one? Also security. Interesting. Now, the ones for stadiums usually aren't that big. It's usually covering the stadium itself, plus like 3 miles or so. Austin.
Are these also going to have an up to altitude?
Yeah, you can say this one says from surface to just 1,000. Hannah.
Okay, so going back to the Tersa, how would we know that we're entering one if it just looks like a Class D?
Aha. It's these gray lines. The gray lines represent the Tersa. Joshua.
For TFRs, I noticed that the effective time is listed in Zulu. Will we have to, are we gonna have like an easy way to convert from Zulu to the local time if we don't know the difference in that particular region?
I mean, if you see a TFR and it doesn't give you the regular time, just look up the nearest airport and see what their plus or minus for Zulu. That's what I would do. Alright. Got some questions out of you. Yay. Alright. I want everyone to vote in the chat. Do you want to take your 5-minute break now or your 10-minute break? All right, I get it. It's the 5. Jeez. All right. So sorry, that was a lot of 5s. So 5-minute break it is currently 9:11. I mean 11 minutes past the hour. So I will see you guys 17 minutes past the hour. Alrighty, and we are back. 5 minutes is over. And I get brownie points because I always give you like 5 minutes or 10 minutes plus whatever other seconds is left in the minute. So you are welcome, okay? Welcome. 5 stars. All right. Now we're going for weather theory. All right. Now, is this the most in-depth? I've taught this lesson before. So is this the most in-depth that you need to go into weather? No. But this is going to cover everything you should know for A, the par, and B, at least get your mind where it needs to be when you get to your training center, you go a little more in depth. Okay. So this isn't everything, but it's definitely a good start to get you going. Okay. So let's do this thing. All right, lesson outlines. Atmospheric stability, atmospheric moisture, relative humidity, dew point, clouds and classification, fog, precipitation, icing, air masses and fronts, thunderstorms, other hazards. All right, here we go. So, atmospheric stability, okay? It's kind of just like the stability that we've talked about previously in regards to the aircraft and aerodynamics. Stability also affects the atmosphere and how clouds are formed as well. So it isn't written here. This is what I tell all of my students. The more stable the atmosphere is, the more the atmosphere resists vertical movement. Okay? The more stable, the more resistance to vertical movement. Okay? Alexander.
Does that mean it'd be harder to climb and get lifted off?
No. Not talking about the plane, I was talking about the atmosphere. Okay. So, if you have very unstable air, look how this is risen so far up. It has risen because it's not resisting vertical movement. Okay, that's unstable. This one down here is still all the way at the bottom because it is resisting any vertical movement. Okay, and then you have neutral. I moved a little bit, changed my mind, and staying right here. Keith.
So an example of the stability and unstable would be like if you flew over the ocean would be more stable, and if you flew over like a city, it would be unstable.
Essentially, yes, but we're gonna get more into it. But essentially, yes. Okay, you're getting there. I like it. I like it. So, once again, you have rising, which would be a very unstable. You have sinking, that would be it's getting more stable, and then you have neutral, she's hanging out. So, the stability of the atmosphere depends on its ability to resist vertical movement. All right. A stable atmosphere is going to make vertical movement very difficult, and small vertical disturbances dampen out, they go away and disappear. If you're in an unstable atmosphere, small vertical air movements tend to become larger, okay, resulting in turbulent airflow and convective activity. And then instability can also lead to significant turbulence, such as extensive vertical clouds and severe weather. All right, so determining stability. How do we determine if the atmosphere is stable or not? Well, stability in the atmosphere can be determined by comparing the lapse rate, what's known as the lapse rate, to the standard lapse rate, okay? Now, what is the standard lapse rate? The standard lapse rate is 2 degrees Celsius per 1,000 feet. I'll say it again, 2 degrees Celsius per 1,000 feet. Now, obviously, as you get higher and higher and higher, that temperature is going to go down. So we're saying every 1,000 feet, if it's stable, every 1,000 feet you go up, it should go down 2 degrees Celsius. Nicole?
Sorry, it took me a second to unmute. So you're comparing the lapse rate to what again?
You're comparing it for the temperature at every 1,000 feet. So that's how you know if it's stable or not, all right? If it's a standard lapse rate of 2 degrees per 1,000 feet, like 2 degrees Celsius per 1,000 feet, you can assume it's a stable atmosphere.
Okay, so you're comparing the lapse rate to the weather.
To the stability of the atmosphere.
Stability of the atmosphere. That's what I was looking for. Thank you. Sorry.
Yeah. We all heard her. She mentioned my weight. My God. Okay, kidding. All right. All right. So if the temperature in the atmosphere is more than 2 degrees per 1,000 feet, more than 2 degrees per 1,000 feet, it is considered unstable. If the temperature per 1,000 feet is less than 2 degrees, it's considered more stable. So less than 2 degrees per 1,000 feet, more stable, okay? More than 2 degrees, so like up, if all of a sudden you're seeing 5 degrees per 1,000 feet, that would be considered less stable or unstable. Blake, do you have a question, face? No? Nicholas?
Can you repeat that one more time? Sorry, you said less than standard. It's
I want you guys to get this down, so I'm more than happy to repeat it. So, if you're seeing more than 2 degrees difference per 1,000 feet, more than 2 degrees per 1,000 feet, it would be considered an unstable lapse rate. Or the atmospheric condition would be considered unstable. That'd be a better wording for it. Then, if the temperature per 1,000 feet is less than 2 degrees, you see less than 2 degrees change per 1,000 feet, that would be considered even more stable. More stable. All right, so these are quite often going to be found on your written test questions. So, in unstable air, what do you see? Well, with unstable air, you have more vertical movement. So you're gonna have cumuliform clouds, the puffy ones. Cumuliform clouds are nice and puffy, right? You're gonna have showery precipitation. Hint here, the word showery is specific to unstable. Showers are from unstable. Okay? Comes down hard and fast. Then rough air, turbulence. Why? Because you have all that rising air hitting you. Then good visibility. Now, why is it good visibility? Because with all that rising air, you're pulling the clouds higher up. So you should have good visibility where you're at underneath them. Does that make sense? Because this rising air pulls the clouds higher up, so you should have good visibility where you are. All right? Then if you have more stable air, okay? You're gonna have stratiform clouds and fog. So let me rephrase, blankety clouds and fog. Not puffy, blankety. All right? Then, continuous precipitation. Think of those days where it's not like thunderstorming, it's not raining super hard, but it's raining literally all day, just like light raining literally all day. That is continuous precipitation, not showers, that's continuous precipitation. Now, you should have smoother air because you don't have all those rising currents hitting you every other second. But you would have poorer visibility. Why? Because there's no uplifting force taking those clouds away. Any questions on that? Okay. Now, get it all out, get it all out. Yeah, good. Okay, so the combination of moisture and temperature kind of determine the stability of the air and the resulting weather, okay? So cool, dry air is stable and resists vertical movement, which leads to good weather, okay? Less thunderstorms, all right? The greatest instability occurs when the air is moist and warm, as in the tropical regions, aka Florida in the summer, where we have thunderstorms literally every day. Every afternoon there's gonna be one thunderstorm, right? So, what's one reason for this? Well, I'm so glad you guys asked. When air is warmer, right? When air is warmer, those molecules spread out more. When they spread out more, there's more room in between them for water vapor. So when the air is warmer, it has more room for water in there. And water vapor is actually has less density than air, right? So that water vapor helps air float up. Okay, that's one reason it's not going to be a very stable atmosphere, because when those molecules spread apart, they get water vapor in them. Water vapor is even lighter than air, and it helps it float up. When it's cold and dry, those molecules are so much closer together, and they don't have as much room in there to put water vapor. Is anybody following me? Okay, cool. Next, there is such thing as a temperature inversion. Remember we talked about how you naturally assume the higher you go, the colder it's gonna get? Well, surprise, there's an exception to the rule. There can be something known as a temperature inversion. So as air rises and expands in the atmosphere, you're gonna expect the temperature to decrease. There is an atmospheric anomaly though that can occur that changes that typical pattern of atmospheric behavior. So when the temperature of the air rises with altitude, you can have what's known as a temperature inversion. Inversion layers are commonly like shallow layers of smooth, stable air close to the ground, like closer to the ground. And the temperature of the air increase with altitude to a certain point, which is the top of the inversion, okay? The air at the top of the layer acts like a lid, right? And when it acts like a lid, it's keeping weather and pollutants trapped below it, all right? So if the relative humidity of the air is high, it can contribute to the formation of clouds, fog, haze, smoke, resulting in diminishing visibility in the inversion layer. So you can see with this temperature inversion, when you have a temperature inversion, you're getting cooler, and all of a sudden it starts getting warmer again. And then and then at the top of the lid, you're gonna start getting colder again. Notice how it was talking about this lid here, how that temperature inversion is acting like a lid, and when this factory most likely wants all the smog to go away, it gets pushed back down, and it creates fog and smog and smoke and stays trapped underneath it. Is there anything on this page? Is that an empty page? Gross. All right, so back to 4th grade science. I know you guys know this one, at least most of these. I didn't know the last one. All right, so when you have water and it becomes a solid, what is it doing? Freezing, right? And when you have a solid that becomes a liquid, it's melting, right? We all know this one. Then, if you have water that goes into a gaseous state, well, that's just evaporation. And when you have from a gaseous state into a liquid, condensation. When you have that, like when you take that Coke can out on a hot summer's day and it gets all wet on the outside, condensation. Now, this not everyone knows, so no judgment, all right? So if you have a gas and it goes directly into a solid, that's known as deposition. Water vapor in a direct solid is known as deposition. An example of this is going to be, ever walked outside when it's super, super cold and everything has frost on it? That's an example of deposition, where all the water vapor in the air started collecting on items and turned into a solid, and everything's just frosted. That's deposition. Last one is sublimation, from solid straight to a gas. Literally the only example I can think of is dry ice. Good? Good. All right, so now we're talking about humidity, okay? So humidity refers to the amount of water vapor present in the atmosphere at one time, okay? So relative humidity is the actual amount of moisture in the air compared to the total amount of moisture the air could hold at that temperature. For example, if the current relative humidity is 65%, all right, the air is holding 65% of the total amount of moisture that it is capable of holding at that temperature and pressure, okay? So you will notice that as temperature in the atmosphere increases, it is able to hold more water vapor. I wonder who just said that. The warmer the air is, the more spread out the molecules are, the more water vapor it can hold. God, like a genius. All right, so next. So to recap, what kind of air holds more moisture? Warm air. Good job, guys. Good job. Good job. All right, so now we're talking about dew point, okay? Get it all out. Get it all out. All right, so dew point, okay? This is the atmospheric temperature, okay, below which water droplets begin to condense and dew can form, okay? I'm going to give my own definition here. If you have a temperature and a dew point, okay, the dew point is telling you what the total amount of moisture currently in the air. This is what your temperature must be cooled to in order to be completely saturated, okay? Your dew point is letting you know what your temperature needs to be cooled to be completely saturated. And when it's completely saturated, water droplets begin to condense and dew or clouds can form or fog, okay? Dew point, what your temperature needs to be cooled to so it will be completely saturated. Questions? Awesome. All right. So, how can we most often get indicators of weather and future weather? Well, you're often going to be looking at the clouds, okay? You're sky gazers now. You're a bunch of hippies. Get used to it, all right? So, bam. Okay, so there are different cloud classifications, okay? What is that cloud's home? Where does it start? What's its base? Get ready to write these down. You have low clouds from the surface to 6,500 AGL. You have middle clouds at 6,500 to 20,000. Woo, that's you, me. All right, 6,500 to 20,000. Then you also have high clouds over 20,000 AGL. All right. You can also have clouds with vertical development, meaning they span multiple homes. All right. Now, next you're going to find out how fluffy they are. Oh, Keith.
Like storm clouds, it would span low to high. How would you classify like a storm front or storm cloud?
Clouds of vertical development right there.
Okay.
Yep. All right, get them all out. Okay, so you need to actually try to figure out how fluffy they are. Okay, there is cirrus, stratus, and cumulus, plus some extras. But cirrus, stratus, cumulus. Okay, now that you have those 3 words written down, it's weird, but I want you to give a dash next to each word, and I'm going to tell you what to associate with each one. Okay? For cirrus, think wispy. Cirrus, think wispy. Okay? For stratus, I want you to think blankety. Blankety. Okay? For cumulus, puffy. Puffy. Yeah. La la la. All right, here we go. So, we also have different names for low, middle, and high. So, cirrostratus, that means high but blankety. Cirrocumulus, high but puffy. And then just straight up cirrus, wispy. Then for middle clouds, you can include the word alto. So altostratus, middle blankety. Altocumulus, middle puffy. Then you have strato near the ground. So you can just have straight up stratus, so low blankety. Stratocumulus, low but puffy. And then nimbostratus, rainy and puffy. Okay, lastly, you can have towering cumulus, which is those clouds with vertical development. Cumulonimbus. Questions? All right, so that's your basics on clouds. When you go outside today, and I hope I pray that at least most of you leave your homes and go outside today. When you go outside today, make sure you look up and try to decide, is it wispy? Is it blankety? Is it puffy? All right, now talking about clouds on the surface, all right, the different types of fog, all right? Think of a fog that's like a cloud that lost its medical, right? It's grounded, right? Usually from about the surface to about 50 feet, okay? We're gonna go over the different types of fog. So, first, we have radiation fog, okay? This really happens when the ground, like, really cools a lot faster than the air around it. And because it's cooling the air on the ground, because since the ground cooled so fast, it's cooling the surrounding air down to its dew point. I'm going to explain that better, the way I was actually taught. So, with radiation fog, because of the effects of terrestrial radiation, that was terrestrial radiation, okay? That's something where at night the Earth is going to cool down faster. That's because of terrestrial radiation. All right. This is only gonna happen on what they say is cool, calm, clear nights, the 3 C's. Cool, calm, clear nights. Okay, now because the earth is colder than the surrounding air, remember we talked about your dew point is the temperature in which the air must be cooled to reach its most saturated level. Because the earth is cooler than the air, it's going to cool the air around it down to its dew point, and that's when you create your fog. Does anyone not understand this? Let me know now or forever hold your peace.
I still don't get it.
Okay, cool. Bullet points. Terrestrial radiation, which means the earth, the ground is cooler than the air, air surrounding it. All right. Now, if it's cool out, it's clear, meaning it's not raining, and it's calm, it's not windy. That air that's sitting just above the earth is going to be cooled down to its dew point because it's touching the ground, which is colder than its temperature. And remember, we talked about dew point is the temperature in which air must be cooled to get to its most saturated. Well, that earth, the cooler earth, is going to cool that warmer air down to its dew point. When something reaches its dew point, it's going to make fog, clouds, things like that. Is everybody with me now?
What causes terrestrial radiation?
That's a question for a physicist or something. I don't know. I just know a fancy word and I like to use it. It's terrestrial radiation. All right. So then we have advection fog. Okay. So I'm going to read the slide, then I'm just going to explain it. Advection fog occurs when warm, moist air moves over a cold surface. Unlike radiation fog, you must have wind to have advection fog. Too much wind, however, and the fog will usually rise and form low stratus clouds. You're most likely to come across advection fog close to the coast because ocean breezes can blow air over the cooler coastal land. All right, my turn. So think San Francisco, right? You have those warm airs coming from over the ocean going over the cooler land. All right, so warm ocean breezes going over the cooler land. All right, when it gets pushed by wind over the cooler land, again, it gets cooled to its dew point and there's fog. Your example again is San Francisco. Alexander.
Does that usually happen at night, I'm assuming?
Night, by morning, closer over to there. Yeah, warm ocean breeze, that's all I know. All right. All right. Anyone else have another question about advection fog? It needs wind, usually from warm to cool, right? You have warm air from the ocean going over the cool ground because of wind. Then upslope, okay? Upslope fog, I'm reading the slide here. Upslope fog occurs when moist air is blown up hills or mountain ranges, and like advection fog, must have sufficient wind in order to form and survive. Another fun fact about the upslope and advection fog is that they do not burn off with the sun as it rises throughout the day. All right, this is what that means. Let's say it needs to have both warm but stable air. That's what upslope fog requires. Warm but stable air. Okay? If it's pushed, that warm but stable air is pushed by wind up a slope, okay? Because of the adiabatic effect or the lapse rate, right? As it goes up and up that slope, it's going to get cooler and cooler and cooler, and it's finally going to get cooled down to its dew point. When it hits that dew point, it's going to create a layer of fog. Now, why did I say it had to be warm but stable air? Because if there's warm, unstable air, as soon as it started going up that slope, it would just continue rising and rising and rising and go away. So it needs to be warm but stable air that's pushed up a slope, and because of the adiabatic effect, also known as the lapse rate, it gets cooler as you go up, is going to get cooled down to its dew point. Now, like it says in the slide here, it actually stays there for like days. All right, upslope fog stays there for a long, long time. All right, next, steam fog. So, have you ever seen those picturesque movie scenes where there's like a thin layer of fog and it sits on top of a lake? Well, that's steam fog. Okay, so steam fog forms as cold, dry air moves over warm water. Cool, dry air moves over warm water. Okay? As the water evaporates from its surface and rises into that colder air, it's going to get cooled down to its dew point and form the fog over the lake. It's going to be a pretty thin layer, but it's pretty. All right? So, think of when you're boiling a pot of water. Okay? When you're boiling that water, it starts to evaporate and it goes into the air that is your kitchen, and it gets cooler, it hits that cooler air and turns into steam, and you can see it. That's an example, like a real life example of steam fog that you could see. Questions on steam fog?
Can you go over one more time what each of these looks like?
I can try. Advection fog. Think of a valley, right? And inside this valley is blocked off from all those winds. So at the bottom of the valley, there's going to be a big layer of fog in the morning because it was a cool, calm, clear night. And that's kind of what it looks like. Upslope fog, up a hill or a mountain. Steam fog, over a lake. Advection fog, San Francisco. Now, another type of fog they don't really put on this slide, but is part of one they can ask you, so I'm going to go ahead and give it to you. There's also such thing as an ice fog. Ice fog. Okay? Now, with ice fog, we're most likely not going to see it in very many different places here. But when the temperature is like far below freezing, you have that water vapor in the air, and it straight up crystallizes in the air. So it is crystallized water vapor in the air, okay? And it creates its own little fog. In the United States, you'd probably only really see this in Alaska, or maybe even like a really cold winter in Denver, Colorado, up in the mountains. Okay? Again, there couldn't be a whole lot of wind for this to happen. And usually the temps are like, when I say it's below freezing, I mean like, if I'm saying Fahrenheit, -25. But I think it's kind of a cool concept. Water vapor in the air just like crystallizing into a fog. Sounds like a sci-fi movie. The ultimate hit of a menthol right there. Okay, so precipitation, all right? How many types of precipitation out there? Is it just rain? Yeah, rain, yes, but also snow, sleet, hail. They're all different types of precipitation. Now, for it to be considered precipitation, it must reach the ground, okay? And it can be liquid or solid, meaning that it could be rain, sleet, snow, hail, things like that. So, who knows the answer? Speaking of reaching the ground, what's it called when rain evaporates before hitting the ground? Anyone know what the answer to this is? What's that called? Good job, Keith. It is Virga. Very nice. Write it down. Virga. All right. So, different types of icing, okay? What types of ice exist? Well, there's induction, there's instrumental, and structural, okay? So, induction icing. So, if we're talking about induction icing, this is like a type of icing in the induction system that reduces the amount of air available for combustion, okay? Reduces the amount of air available for combustion, okay? This is mostly going to be considered like carburetor icing, all right? So that is that type of induction caused by the effect of fuel vaporization. I see not fuel vaporizations. Fuel vaporization. So you have air coming through here into your carburetor, going through the venturi. And when it does this, it's going to drop in temperature. And if you're in between, if the air is humid enough, so you have water vapor in that air, it can turn into icing inside your carburetor. All right, it's going to block the amount of air, fuel air mixture that can get through. Okay. Carb icing is usually going to form when you are below 21 degrees Celsius and the relative humidity is above 80%. So below 21 degrees Celsius and relative humidity is above 80%. Now, what are the indications of carb icing? Well, you're going to have a decrease in your RPMs, and usually your engine is going to run a little roughly. Okay, decrease in RPMs, and you can have a little rough running engine. Alexander.
I thought carburetor icing could happen at 70 degrees Fahrenheit with 80% humidity.
We're going to get that to in a second. So remember, at first, I at least got to read what they say first. We're almost there. All right. So, what do you see first is a drop in that RPM and usually some engine roughness. Now, when you apply your carburetor heat, all right, if you think you have carb icing, you're going to turn on your carb heat. Okay? Now, when you turn on that carb heat, here's what's going to happen. You already had a slight drop in your RPMs because of the carb icing in the first place. When you turn on that carb heat, you're going to see yet another further drop in your RPMs, but then it's going to gradually go back up. Okay, I'll say it again. When you first see carb icing, you're going to see a drop in RPMs and some engine roughness. So you turn on that carb heat. When you turn on that carb heat, you're going to see a further drop in RPMs. And then, as that ice is slowly removed, you're going to see a slow, gradual rise again. And then if that engine is still a little rough, I would just adjust your mixture at that point. All right. So, another type of intake icing. That's the second type of induction icing, which is basically just blocking the air intake. Okay? There is a filter inside your aircraft to collect foreign contaminants, but the intake port can still get blocked. Okay? Alternate air source must be available. In your aircrafts, you do have an alternate air source just in case. Now, your carb heat air is taken from a different intake than the primary intake, so that's good. So carb heat technically could be used as an alternate air intake. That's just like the more you know type of information. Alrighty, so I know this slide says below 21 degrees Celsius and 80% humidity. Who knows what you guys are actually studying in your par? What does it say? What does it say when you're studying for your par?
It just says 70 degrees Fahrenheit.
Yep. That's the answer you're looking for in the par. Okay. Now, next we're going to talk about instrument icing. Instrument icing, no big deal. Thank you, Kyle. When you are on instrument, getting instrument icing, it's usually talking about your pitot tube or your static port, because those are your instruments, right? So those are gonna be, those are getting iced over is your pitot tube or your static port. What do? You can apply pitot heat. All right, Joshua.
When you say using an alternate air source in the event of the air intake being blocked, are you talking about something other than the alternate static air source? Is there like a separate switches for that?
Yes. Now, to start talking about structural icing. All right. So structural icing is on the surface of the plane. Okay. Now, you need two conditions for structural icing to form. Two conditions for the icing to actually form. One, you need visible moisture. Visible moisture. What does that mean? Clouds, fog, precipitation. Okay. So you need visible moisture, and you need aircraft surface temperatures below freezing. Now, some structural icing is harder to see or detect. So it's important to know the weather, the freezing levels, and what conditions would cause structural icing to form. So that you know if you're in those type of situations, you can suspect ice without even seeing it. So there are three types of structural icing. All right. The first type is clear. Okay. Clear ice forms when those supercooled droplets hit the wing and they don't freeze immediately, so they burst. And when they burst, they spread out like a sheet on top of your wing. Okay? So you have really cold droplets that are going to come down and hit your wing. They burst, and when they burst, it's it's going to spread out like a sheet over your wing. All right. As you can see here, it's very clear, hard to see. All right. Then you have rime ice. All right. These are ice droplets or like super cool, also super cool droplets that are already frozen, or they freeze the very instant they hit the wing. Okay. So they don't have time to spread out and make a sheet. As the moment they hit your wing, bam, they freeze to it. So because they freeze so quickly, the oxygen inside the supercooled droplet does not have time to escape. Because that oxygen does not have time to escape the droplet, it's going to get like a milky or rough looking quality to it and is more easily identified. All right. Lastly, you can have mixed structural icing where you get a bit of both. Questions on this?
Rime icing is basically just colder clear ice.
I wouldn't exactly talk about it that. Like rime ice is, those droplets are coming in, they're usually a lot smaller, and because they're a lot smaller, when they hit, they don't have enough to just burst and spread out, so they just freeze directly to it. Alexander.
Does ATP Aircraft have any systems on board to get rid of rime ice in midair?
No. All right, what is an air mass? Okay. An air mass is a larger body of air with a generally uniform temperature and humidity. All right, a body of air with uniform temperature and humidity. Okay, say it one more time for those of you who can see not taking notes. An air mass is a body of air with generally uniform temperature and humidity. All right, now the area over which that air mass originates is usually what provides its best characteristics. So if it stays in that one area, cool. But when it starts moving around and touching a whole bunch of different air masses, it creates what's known as fronts. Okay? The boundaries of air masses are called fronts. The boundaries of air masses are called fronts. Okay? What I say. A front is the leading edge of the moving air mass where it comes into contact with the foreign mass. Got it. All right. So we're going to go through a lot of fronts in the next few slides, okay? So, big picture, all right? A warm front, red. Warm front, red. Cold front, blue. Cold fronts, blue. Okay? Let's start there. So, a warm front is when an advancing warmer air mass, right, is trying to replace or push out a colder front. Okay? Now, they're usually slower moving in comparison to cold fronts. They're usually slower moving, and they're usually characterized by rising warm air. Now, how to describe this? When a warm air meets up with a cold front, okay, it's lighter than the cold front, so it can't really like push it up or anything. So all it does is it comes over and it leans on it. The warm front's gonna come over and lean on the cold front, okay? When it does that, we get these effects. So, at the front, you're gonna get poor visibility, okay? It's not sending air up, it's just leaning on it, right? So you're gonna get clouds that are just there, all right? So poor visibility. Don't put the word showers here. I take away that word. Do not put showers here. Steady precipitation or continuous precipitation. Put that here, not this. Okay? And low stratus clouds. Low blankety clouds. Then, after the front, temperature going to increase. Air becomes more saturated with water. Okay, so at the front, poor visibility, continuous precipitation, low stratus or blankety clouds. After it's already passed, you're going to get warmer out, therefore more water in the air. Now, if we're talking about a cold front, okay, the cold front is that advancing mass of air that replaces a warmer mass. The cold air is heavier than the warm air. So it's able to like act like a snow plow and go underneath the warm front and force all that warm, moist air up into the sky. It's not leaning, it's putting her up. Okay? Now, it's generally going to be faster moving in comparison to warm fronts. Yeah, and these are the effects. Now, at the front, gusty winds, some more poor visibility. This is where you get those heavy rain showers. Now you're getting those heavy rain showers, thunderstorms, hail, things like that. Okay? Then after that front has passed, well, it's already gotten rid of all the clouds and sent them all away. It's sent it up in the sky, right? So you have greater visibility, but you can have cooler weather. We like that, that's good. And rising barometric pressure. Everybody's still with me. Okay. Now we're talking about an occluded front. Let me jump back. This purple, occluded front. Purple is going to be your occluded front. All right, so think of, it's like a really bad menage a trois. All right, you have a cold front bumping up against another cold front. In between them is leftover warm air. Okay, so you're gonna get effects from all three. A cold front, bad. Cold front, another bad. And then that is pushing as the double the effect of pushing more warm air up into the air. Okay, so when this is happening, purple line, you get the worst types of weather. Okay, cold front times 2. So this is gonna be squall lines, tornadoes, things like that. Alrighty, stationary front. Okay, this is where you have a cold front and a warm front that are like, they have equal power, okay? And they're bumping up against each other, and one's not overtaking the other. They're just bump, 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 bump. And you're gonna get effects from both. And this is the one that's gonna stay the longest. Because one's not pushing the other one out. They're just gonna keep on bumping up against each other, and it's gonna stay for days. Days. All right, what is that thunderstorm? Well, this is one of the most hazardous things that you can try to be around in aviation. All right, I'm gonna have a quick slide on each of them. So, first we have the different stages of a thunderstorm. Okay, first you have the cumulus stage. Okay, the cumulus stage. What the cumulus stage is all about the updrafts. Okay, it's all about the updrafts in the cumulus stages. Is making that towering cumulus. Okay, then you have the mature stage. Okay, the mature stage has begun once precipitation begins to fall. Mature stage, that there's going to start to be precipitation. Lastly, you have the dissipating stage. The dissipating stage is marked by downdrafts. Downdrafts. So cumulus stage, updrafts. Mature stage, precipitation. Dissipating stage, downdrafts. Cool? Cool. All right. So the effects, right? Well, you can be, they say to be about 20 miles away. All right, you can have severe turbulence because of thunderstorms. You have updrafts, you have downdrafts, you have precipitation, you got lightning, thunder, the whole schmagegi, right? So, severity of that turbulence is directly proportional to the instability of the air producing the cumulus cloud. Obviously, with this cloud, that is a lot of updrafts that were just happening there. And then through here, there's a whole bunch of combination of updrafts and downdrafts. And then once it starts dissipating, That's gonna be a lot of downdrafts at the all same time. So all those upflows and downflows are really gonna create all your turbulence. Now, wind shear, okay? So wind shear is the definition, that sudden and drastic change in velocity and direction, all right? Wind with a sudden and drastic change in velocity and direction. Okay, so when you have wind shear, you're gonna see huge changes in your airspeed happening all at once. That's what's gonna happen with wind shear. It's not very conducive to trying to land a plane. Microbursts. All right, so microbursts. Microbursts are rapidly descending columns of air. They can have these columns descending up to 6,000 feet per minute. That's how fast that column of air is descending. Now, when you're trying to fly through near a microburst, first, when you're in front of it, you might think, all right, I'm getting better performance. Why are you getting better performance? Because you have all that headwind coming at you. All right. Then you get directly underneath it. It's going to push you really far down. Now, if you're able, by some miracle of whoever, to get through that, on the other side, you don't have any headwinds. You only have tailwinds on the other side coming out here. So you have much less performance. And even though you're trying to climb, because all the air just pushed you down, you can't really climb as much, so you don't have as much performance. You don't have enough headwind. You can see here, this example, this ATP aircraft was on the ground. Someone was silly and didn't do their tie downs, and what happened? It flipped over. I wonder if this. Go ahead.
How did you define microburst at the beginning? One more time.
A rapidly descending column of air. Usually happening in and around thunderstorms. Now, there are some airports out there that have microburst tracking capabilities. When I say tracking, I don't mean like they can tell when they're going to happen. There's airports out there that can tell when they are happening. Okay. And one really good sign of a microburst is Virga. And another sign, like on top of that Virga, is with that rapidly descending column of air, it's going to pick up a lot of dust and things from the ground. Without the air coming down that fast, all the dust in the area is going to start picking up and billowing out. That's another big sign of a microburst. All right, lightning, right? So let's read it off. The FAA estimates that lightning hits a plane once every year. This on average is once every 1,000 hours of flight time. However, this can all depend on what routine the airline flies, with as some geographical spots are more likely to be hit. With research finding that lightning is more likely at intermediate altitudes of 8,000 to 14,000. Those that do not get struck by lightning should rest assured, as planes are now fixed with lightning protection equipment, which can protect the aircraft up to 30,000 amperes. Well, on our aircrafts, we have something known as static wicks. Static wicks. Now, these static wicks, their main function is as air travels over your wing, it can pick up static electricity. And as it picks up that static electricity, those static wicks help diffuse all that static electricity coming onto your wing. So the static wicks has a second function, that they're supposed to dissipate energy if lightning were to strike your plane. Would it actually work? That remains to be seen, but that's supposed to be what they do. Cool. Zeus says hello. All right, hail, right? Now, it's important to know that it does not have to be freezing out for there to be hail. Now, with this hail, you can see what kind of damage it can do. This is a big boy. This ain't no Orcha, no Cessna. This is a big boy. And this is a lot of damage that it received just from hail. Hail is the #1 reason that the FAA recommends that you stay away 20 miles from thunderstorms, because hail can travel on the winds and actually come and hit your aircraft. That was 20 miles away from thunderstorms is what the recommendation is from the FAA. Straight up. Tornadoes. Don't need to say much, it's a tornado, right? Now, which way do tornadoes turn? Clockwise or counterclockwise?
Counter.
Counter. That was a very quick answer. Very nice.
I live in Denton, Texas, so we get a lot of them.
Gotcha. Gotcha. All right. So how far should I steer it clear? 20 miles or more. All right, next, squall line. Okay. So squall lines. All right. Think like a really long line of thunderstorms. Okay. Now, with that really long line of thunderstorms, they kind of build on each other. Okay. They give each other energy. So they end up being like the 300 right there, and they all spread out. Okay. Now, because it's such a long line of thunderstorms, the thing is, if you see one, you're like, oh, I'll just try to go around it. No, it's too long. You can't get around it. And way too dangerous to penetrate. So if you see a squall line, that means turn around. Okay? See a squall line, you can't really go across, you can't go around it. Too dangerous to go through it, just turn around. All right, so you can also have really low ceilings. That's going to be not letting you have your VFR weather minimums, right? That's going to give you restrictions to visibility. Volcanic ash, right? Totally a thing. Volcanic ash is not just smoke, right? It's made of really small particles of rock and glass. You don't want that getting into your engine. So not only you can't see, you're ruining your engine in the middle of the flight. Our combustion engines cannot handle that. Now, this one's important to note. Okay, you guys need to write this one down. Okay, so the turn of phrase is from high to low, look out below. So if your altimeter is not set to the current altimeter setting when flying from an area of high pressure into an area of low pressure, the aircraft is going to be closer to the surface than your altimeter actually indicates. Okay? I'll say that again. From high to low, look out below. If you go from an area of high pressure into an area of low pressure, and you do not reset your altimeter setting, you will be much closer to the ground than your altimeter is actually saying you're at. Cool? Cool. High to low, look out below, lower. You are lower than your altimeter indicates. That's what they're saying. All right. Questions? Nicholas.
Now, the reverse to that would just be low to high, clear the sky, right?
Yep. Joshua.
there were some questions I saw about how high pressure systems rotate compared to low pressure systems.
Yeah, so high pressure systems, they rotate clockwise, outward, and downward. Okay? Low pressure systems, they rotate inward, upward, and counterclockwise. Really? That's it? No other questions? Austin.
Yeah, is there a way to calculate how far off your altimeter is? Like if you're supposed to be at 2995 and it's set to 3000, like how many feet off are you, if that makes sense?
So every inch is 1,000.
Okay.
Kayla.
In some of the PAR questions that I've taken, they mentioned like MAMA nimocumulus clouds or nimbocumulus clouds.
The nimbocumulus clouds? Nimbocumulus is just rain clouds.
It's like MAMA, like MAMA.
I'm sorry, I'm not familiar with mamatas. I haven't seen it since the PAR, so I couldn't tell you, honey. I'm so sorry. Let's look it up. MAMMATUS. Ooh. It looked blankety but drippy. What are Mama Mata's clouds? Oh, gross, don't do that.
What are Mamatus clouds? You know those pouch-like protrusions you sometimes see hanging from the undersides of clouds? They often come with or just before severe weather. They're called Mamatus clouds, and they're fleeting, remaining visible for maybe 10 or 15 minutes at a time. Most clouds are formed by rising air, but these clouds are formed by sinking air. Enjoy these photos of these ominous, beautiful clouds from the Earth sky community.
Oh gosh, no. Seems like a cult. Yes, all right. So now we know what Mama Mata's clouds are. All right. Any other questions? Paul, I've been waiting for your question. You were very silent today.
I'm a little confused by stationary fronts because if you have two fronts that are abutting against each other, I mean, due to the Coriolis effect, wouldn't weather naturally travel in the northern hemisphere is west to east? So one front that isn't traveling in the same direction as the other.
Just the rule of thumb, especially when you get to the PAR, it's just because they're the exact same energy and one can't overtake the other. While
So
there could be winds that are blowing, but the two air masses themselves are just bumping into each other.
So the one front that is traveling, I guess, east to west would have to be relatively a lot stronger than the one that's going west to east.
Most likely, yeah. I see what you're saying. Yeah. Who else had their hand up? Demi.
So my question was, so a microbus first, you can fly in it with with the little ATP planes. So flying into it would be fine.
No. Flying into the microburst is a big no-no. So it's a miracle when jets make it through without crashing.
Okay.
Nicholas, do you have question face? No. All right, how about you, Kyle? Casey? Nicholas?
Sorry, the only question that I would have would be like, how would I know which airports have like the detection system for the microbursts?
Well, when you have a system that has a microburst on it, ooh, I want to make sure I say this right. You're gonna do. There you go. You see that as LLWAS, TDWR, and WSP system. All right, last question, Joshua.
Can you explain to me how how Coriolis effects differs between the northern and southern hemisphere?
All right, taking me back. All right, Coriolis, it goes from, it has an eastbound in the northern hemisphere. And if I'm remembering this correctly, because I don't have to talk about the southern hemisphere like ever. As far as I know, it's the opposite in the southern hemisphere. But I'm not an expert about there. I just had to learn about here. All right, 10-minute break time. I will see you guys 39 minutes past the hour. All right. It is 39 minutes past the hour. So now we're gonna do weather forecasts and reports. All righty. All right, I'm awake, I swear. Let's do this. Weather forecasts and reports. Everyone's popping back on. Love to see it. All right, cool. So, observation versus forecast. All right. Obviously, observation is what you're observing right now. Forecasts are what experts think will happen next. Now, observations are used to create forecasts. All right. Now, historical weather observations can help predict weather trends over seasons as well. So, there are several locations where weather can be observed and recorded from. Okay? They can be observed and recorded from the surface, from an aircraft, from a satellite, from a weather balloon. Okay? All right, so there's three big types of weather observations for general aviation. Take a little look at each. All right, first, we're talking about AWOS, ASOS, okay? So regular updates that give you live weather on a field, okay? Now the weather equipment and data is considered good weather information within 25 nautical miles and under 10,000 feet, okay? That was within 25 nautical miles and under 10,000 feet. Now, the Automated Weather Observing System, AWOS, is similar to an ASOS, but is usually owned by the state or the airport. Okay? It provides most of the same information as an ASOS, but more sophisticated AWOS do have the ability to add voice information to the broadcasting regarding NOTAMs, but not all. Okay? Now, the number that you can see next to the AWOS, if you're looking at like the sectional, it says AWOS-3, indicates the complexity of the on-site equipment. Okay? Now, the ASOS, or the Automated Surface Observing System, is another example of an in-flight weather observation. It is an automated machine owned by the National Weather Service, that provides current weather information. Now, an ASOS is primarily found at like uncontrolled fields or uncontrolled airports, and is an automated computer-generated voice recording that updates minute to minute. Okay? This is unlike the ATIS, right? Which is recorded hourly by your controllers. The ASOS rarely has a human observer. Okay? Kind of important to note, the ASOS will not give out any NOTAMs or any other information. ASOS is just purely weather. Okay? All right, so like we said, that number next to AWOS refers to the capabilities of the robot, right? The higher the number, the more technology there is. Now, you can get the data using aircraft radio, because we can see the frequency right there. So if you're in air, you can just tune into this frequency. If you're close enough, you'll be able to hear it, right? You can get a cell or a landline phone. When you go to ForeFlight, if you look up their AWOS frequency, most likely it'll give a phone number at the same time. You can use your internet. So you can go to many different weather reporting systems and visit them online, or a flight pad, right? So think internet in the plane. Now, for a METAR, what does METAR stand for? Meteorological Terminal Aviation Routine Report. That's a mouthful. Meteorological Terminal Aviation Routine Report. Now, a METAR is an aviation routine weather report. It's an observation. The METAR is an observation of the current surface weather reported in a standard international format.
Can you repeat what you just said real quick?
Absolutely. So that METAR is that aviation routine weather report. It's an observation of the current surface weather reported in like a standard international format. Now, get it all out. All right. So I'm sure you guys have all done your intro flight by now. And for those ones you start actually getting to your training centers, once you start flying a few times, you're going to become familiar with ForeFlight and how those METARs are portrayed there. Learning to read an untranslated METAR is essential for your check rides, okay? Actually being able to read a METAR is very essential for your check rides. You will be asked not only in your private check ride, but most likely every check ride after that as well. Now, METARs are usually issued on like a regularly scheduled hourly basis, unless there's been a significant change to the weather. So they're supposed to come out once an hour, but it will change that and do less than an hour if there's been a significant change. Okay? Now, in the event that significant change has occurred, a special METAR known as a SPECI, that is, it'll literally be typed out like this. Oops. SPECI. If it comes out with that, you know that this is a special change that has come out in less than an hour. Now, a very commonly asked question that students get on their check rides. I want to throw this out there real quick. METAR winds are reported in true direction, not magnetic, true. All right? METAR winds are reported in true direction. All right. We're going to try to read through one. Okay? It's a nice, simple one. Okay? So, here we go. First here, we have the ICAO identifier of the airport. Kappa. That's the ICAO identifier of the airport. Okay? Next, this is talking about the day of the month and the time in Zulu. So this is the 7th day of the month at 1853 Zulu. That's when this was populated. 7th day of the month at 1853 Zulu. Okay? Now, this is talking about the winds, okay? So the winds are coming from 010 at 8 knots. Does everybody see that? It's coming from 010 at 8 knots. Okay? This is talking about your visibility. You have 10 statute miles of visibility. Next is talking about the clouds. You have few clouds at, and like many times in aviation, you have to add 2 zeros. So you have few clouds at 8,000 feet. All right. We have your temperature and your dew point. When you see this slash like this, it's talking about temperature and dew point. So your temperature is 27. Your dew point is 12. Temperature 27 slash dew point 12. Your altimeter setting is 2, 9, or 9, or 4. A for altimeter setting, 2, 9, or 9, or 4. Doing good?
What was the last one?
So this A is referring to your altimeter setting. So your altimeter setting is 2, 9, or 9, or 4.
Could you repeat the second to last one?
This one?
Yeah.
Yeah. So when you see this slash right here, you need to recognize it as temperature slash dew point. So the temperature was 27 slash your dew point is 12 degrees. So it's 27 degrees Celsius, your dew point is 12 degrees Celsius. All right. Are clouds reported in AGL or MSL? Good job, Blake, AGL. All right, like I was saying, if you're gonna have an extra weather report come out before the next hour, it's known as a speci or a special report, all right? That's where you get that funky weather, okay? All right, so PIREPs, okay? So a pilot report or a PIREP is a report of actual weather conditions encountered by an aircraft in flight. Now, this information is usually relayed to the by your radio to the nearest ground station and the nearest flight service station. Okay, so if another, like, this is not just, hey, based on the clouds, we think there should be some turbulence, or this is what we think it should be up there. This is what is actually happening at that time. So the PIREPs are very good information. Daniel.
Yeah, I'm sorry. Could you repeat the concept again?
Yeah.
Thank you.
So a PIREP is a pilot report, okay? This is an actual report of someone who just went through, who's just flying up in the air and what they are experiencing. They're going to report it like 99% of the time via the radio to their nearest ground station or flight service station, okay? Now, when they're reporting this, it's not just some weather system saying, it like a computer saying, I see clouds, there must be turbulence. No, this is an actual pilot going through there and saying, this is what it actually feels like. So PIREPs are very important. They tell you a lot of real information. Keith. Honey Bunches, you're muted.
How long are the PIREPs good for? Just like 15 minutes or half hour, since it's current data?
Let me make sure I'm saying it right. So it says valid beginning time or 6 hours and 15 minutes. No, that's not it. Pyrex offer the most accurate information, valid for 5 to 10 minutes after submission. Okay, so PIREPs are really encouraged in virtually all airspace. In some parts of the world, air traffic facilities are actually required to solicit or ask you guys for PIREPs when a few different conditions are reported or forecasted. So if the ceilings are below 5,000 feet, ATC is like required to solicit or ask for PIREPs from certain pilots. So if it's less than 5,000 feet or visibility less than 5 statute miles, they're gonna start asking for PIREPs. Now, you can ask ATC about the weather if they're busy. The real people that you want to talk to are the flight service stations. All right. So with those flight service stations, we talked before about 1-800 WX brief. Those are the people you call for a weather briefing. Those exact same people are the people that run the flight service stations. Okay, so they're legit. Okay, so when you're calling for a PIREP, you want to give one, you're most likely to give it to a flight service station. All right, so when it comes to forecasting, okay, so planning ahead with weather is never certain. All right, the further out you look, the less accurate our predictions become. All right, this is why we try to usually wait around for weather. Like it could be forecasting thunderstorms, and the hour that it says it's gonna be thunderstorms, there's a whole lot of nothing, right? It's clear in a million. So do not get mad at your instructors when they are slow to cancel. They've been there and they've had situations where they canceled for weather and then the moment came and it was absolutely fine. So it happens. Okay, so NexRad is a weather system that you have in your aircraft, okay? And when you are using NexRad, it's not where the thunderstorms or precipitation is now, okay? It's where it was up to 8 minutes ago, okay? So when you're flying around and using NexRad in your aircraft, you're like, it's good for situational awareness to know where things were just shortly ago. But if you're trying to shoot the gap between two thunderstorms, you better not be using NexRad because that could be really out of date. That could be up to 8 minutes out of date, and those thunderstorms are going to be moving. So is it really that reliable? No. Is it good for situational awareness? Yes. It's great to be able to see on ForeFlight or on your in your aircraft, oh look, there's thunderstorms in the area, because it can tell you that, but it's not up to date right now information. Okay? Showing where weather was, not where it is. Okay, so types of different forecasts. We have the TAF versus the MOS, gross. Winds and temperature aloft. Why the acronym for winds and temperature aloft is FB, no one knows. No one knows. Then there's SIGMETs and AIRMETs, okay? So let's take a closer look at each. So when we are talking about TAFs, okay, there are 122 weather forecast offices. So they all work on those tasks throughout the United States, right? Now, the TAF is good for within a 5-mile radius around the airport, okay? Not very far out, so usually just the airport itself. Now, it's written by the people of the National Weather Service. That's great, okay? And it says typically good for 24. It can go up to 36 hours. 24 to 36, but usually going to see them for 24. All right, reading the TAF. Kind of similar to a METAR, but like different wording to it. All right. So, just like before, we had the airport identifier KJAX, right? So for Jacksonville International KJAX. Now, just like the METAR, when this was issued, right, the 7th day of the month at 1720 Zulu. Okay. Now it's talking about in this next section, what is its valid period? Okay, where this TAF, it covers from when to when. That's what the valid period means. What is this actually covering? Okay, it's covering from the 7th day of the month at 1800 Zulu to the 8th day of the month at 1800 Zulu. Okay. Okay. So, go back. So just like the METAR, winds are coming from 010 at 11 knots, from 010 at 11 knots. Okay. When you see this P in a TAF, the P means plus. So over 6 statute miles of visibility. Okay? The P is for like a plus, so you're getting over 6 statute miles of visibility. SKC is a good example of sky clear. SKC, sky clear. Now, when I see FM, I say the word starting from. So we were starting on the 7th day of the month at 1800 Zulu. That's what this was covering, right? The 7th day of the month at 1800 Zulu. That's what this is covering. Now, starting from the 7th day of the month at 2300 Zulu, wind 040 at 7 knots. Over 6 statute miles of visibility, sky clear. And the next one would have another FM down here. So starting from whatever time and date, this is the winds, this is the visibility. Let's get another example. I feel like that wasn't a very good example. Nicole?
Would you ever see something besides sky clear?
Yes. We'll see that in 1 second here. All right, let's say. All right, let's see. Joshua, what's up?
Is the what is this called? The terminal airdrome forecast, the TAF, does that also give winds in true direction?
Yes. All right, let's see. I see Kayla. Kayla comes from CRQ. Let's look at that one. KCRQ. All right, let's zoom in. So, at KCRQ, the terminal area forecast, all right, this was developed on the 9th day of the month at 11:40 Zulu. This is valid from the 9th day of the month at 12 Zulu to the 10th day of the month at 12 Zulu. Wind 060 at 3 knots. All right. Plus or over 6 statute miles of visibility. Now, you see this little negative? The negative here means light. So light, showers, and rain. Light, showers, and rain. Few clouds at 2,400. Remember, always add 2 zeros. Broken at 3,500. Always add 2 zeros. Broken at 5,000. Always add 2 zeros. All right. She has a tempo here. The tempo is saying that it's not going to last very long. It's from the 9th day of the month at 12 Zulu to the 9th day of the month at 16 Zulu. 5 statute miles of visibility, light showers and rain, broken at 2,500. Always add 2 zeros. Then we go into the FMs. Like I was saying, every time you see FM, just say starting from the 9th day of the month at 1800 Zulu. Winds 190 at 5 knots, over 6 statute miles of visibility. This showers in the vicinity, VC for vicinity, so showers in the vicinity, scattered at 2,500, broken at 3,500, and on and on and on. DJ.
Can you say what the sorry, can you say what the few meant again?
Okay, so you know how the FAA likes to be really weird? Well, this is one of those moments. So what they did was they broke up the sky into eighths. That's right. 1, 2, 3, 4, 5, 6, 7, 8. They turned it into eighths. And if 1 to 2 eighths of the sky is covered with clouds, that's few. Okay? 3 to 4, that's scattered. So 3 to 4 eighths, that's scattered. 5 to 7 eighths, that's a broken. And broken is considered a ceiling. Okay? And then of course, 8 eighths is just overcast. That's what I just said, Blake. I said it first. Ha. All right. Anyways, that's DJ. Let's look up her airport. KCOS. All right. 9th day of the month at 1444 Zulu. This is valid from the 9th day of the month at 1500 Zulu to the 10th day of the month at 12 Zulu. Wind coming from 330 at 7 knots. 3 statute miles of visibility. Ew, light snow? Gross. You chose to live there. All right, BR. Okay, this is one of those funny codes. They call it, it stands for mist. BR. We pilots call it baby rain. Mist. Baby rain. All right. Scattered at 3,000, broken at 7,000. She also has a tempo in there. From 1500 Zulu to 1700 Zulu, 2 statute miles of visibility, light snow, mist, scattered 2,000, broken 4,000. Girl, you got some poopy weather. Gross. All right. Hopefully they can give you guys some seedlings on TAFs. Oh, I get that. I get that. All right. So now we're talking about the MOS. Okay. This is the model output statistics. Okay, the model output statistics, excuse me. All right, so what does it do? This builds on your original forecast model by taking into account like historical records of observation at forecast points, and it tries to like remove any model biases and quantifies any uncertainty into like probability forecasts. It's a computer that's using historical data and a formula to predict what the weather's gonna be. I'll say it again. It's a computer that's using historical data, what's happened before when weather was like this, plugging it into a formula, and giving you a probability forecast. So is it reliable? Not really. All right. All right, so advantage of the MOS. Mathematically simple yet powerful. Non-linearity can be modeled by using NWP variables and transformations. Okay. Probability forecast possible from a single run of NWP model, removal of some systematical model bias. It's basically saying I'm a computer, so you all have opinions. I take opinions out and use facts. Limitations. Needs the historical record, right? Short-term sample periods cannot be used. And changing the NWP models means reconfiguring equations with a simple set. All right, in short, robots develop the MOS and humans create the TAF. Which is better, you decide. We can't let the robots win. We have to say we're better. All right, the wind and temperature aloft forecast. You guys will be using this a lot. Again, no one knows why the acronym for winds and temperature aloft is FB. No one knows. It is. So it's in that KO term. And this is updated twice a day. And as it says, it's going to give you the different winds starting at 1,500 feet and start giving those different temperatures starting at 2,500. So remember when we were talking about when you're trying to judge the stability of the atmosphere, you're looking at the temperature every 1,000 feet? This is what you would look at because it's going to give you the temperature every 1,000 feet. So this is what you're actually going to look at. All right, so this is also very key. Oh, Paul.
I assume that's AGL.
For the winds and temperature aloft?
Yes.
Yes. No, MSL. I take it back. It's MSL. Let me double check.
Okay.
Wait,
So
let me
Denver.
double check. Now you got me thinking about it.
All right.
And all right, wind forecasted winds aloft. Is it do? I mean, the winds are true. We know that. Do. Shoot, doesn't say on this page. By the end of class, I have your answer, Paul. I want to make sure I get that one right. Okay, I'll let you know.
Okay.
Joshua, what's up?
So is ATIS the only thing that gives wind in magnetic direction?
Yes. If it's written down, the way they say if it's written down, it's usually true. If they say it's usually magnetic. That's the general rule of thumb. All right. Cool. So, especially when you're doing cross-country flight planning, you really want to look at the winds and temperature aloft, because that way, as you're planning your route, it'll be telling you where that wind is coming from. Therefore, you'll be able to tell, hey, if I go to this altitude, maybe I have a really big headwind. But if I go up to this altitude, you're going to be at might have a tailwind. Aha, I was right. Paul, it is MSL. MSL. Ooh, who can tell me what the approximate ground speed should be? What do you think? It's okay. It's okay. I'll give it to you. Don't worry about it. So, oh, Keith, go ahead.
Approximately 45 knots.
Ooh, I like it. Good job, Keith. So what you're doing here is you're going to take your true airspeed, and because your true airspeed, how fast you're flying through the air, then you're going to take out your headwind. So if you have a 50-knot headwind coming at you, you're probably going to go about 43, and this is a little off center, so it might be closer to 45 over the ground. True airspeed, how fast you're going in the air. So if you have a headwind, it's going to slow you down over the ground. All right. Get it all out. Okay, so air mets, okay? Air mets are directed at small, light aircraft. So air mets is more specifically for general aviation. Now, all people of aircrafts with all different sizes are going to actually pay attention to air mets, but they're specifically designed for general aviation. Now, the purpose of an air met is to warn of potentially hazardous en route conditions, right? They cover wide areas and allow you to quickly get an idea of potentially hazardous conditions you can encounter when you're flying through a zone in an air met, okay? So air mets are issued to all pilots to enhance safety, but they mostly concern general aviation and pilots without an instrument rating, okay? So they're usually going to cover different things such as turbulence or surface winds over 30 knots, icing conditions, and widespread low visibility or mountain obscuration. They are valid for 6 hours. It's not saying it, but it's letting you know. Air mets are valid for 6 hours. Now, they go into 3 different types, okay? So, there's 3 types of air mets, right? They each have a letter identifier to describe their weather hazard. So, if you have an air met Sierra, or air met S, that's talking about that mountain obscuration and or the ceilings less than 1,000 feet or less than 3 statute miles of visibility. Okay? The way I try to remember it is air met Sierra, like Sierra Mist, IFR conditions. Okay? Then you have air met Tango, Tango for turbulence. Okay? Air met Tango for turbulence. It's moderate turbulence or sustained surface winds of 30 knots or greater. That's what they do a Tango air met for. Lastly is the Zulu air met. Okay, the Zulu air met. Now, moderate icing and freezing levels. Notice here, one important word I want you to make sure you get down here. Moderate turbulence. Moderate icing. Okay? Moderate. Big word there. Okay? All right. So, Now we're going to segments, all right? Segments, this is starting into the really bad stuff, all right? So segment, significant meteorological information, okay? Now the purpose of a segment is to warn of potentially hazardous en route conditions, again, for more severe than contained in an AirMet, okay? So the issuance of a segment includes like severe weather, such as, now this is important, severe icing, not associated with thunderstorms. Severe turbulence, again, not associated with thunderstorms. And then I kind of think of it as severe IFR, but what it means is like dust storms, sandstorms, volcanic ash, okay? Severe as in deadly IFR, all right? So everything that we had in AirMet, but now next level, okay? But notice how I said twice in there, we're just talking about just a segment that is not related to convective or thunderstorm activity, okay? Now, when we start talking about severe icing, severe, exactly what I just said, severe turbulence, dust storms, sandstorms, volcanic ash, the severes, okay? But now, also, remember how we said AirMets for 6 hours? Segments for 4 hours. AirMets 6, segments 4. All right. So, when we start talking about actual thunderstorms, now we're saying convective segment. Convective segment is thunderstorms, okay? So, they're including severe thunderstorms with surface winds greater than 50 knots, okay? There's gonna be hail at the surface greater or equal to 3/4 of an inch in diameter. Tornadoes. Embedded thunderstorms. Who can tell me what an embedded thunderstorm is? Joshua.
Is that when it's within like a cloud layer so you can't see it?
Yeah, you fly through, think it's a regular cloud, and bam, it's a thunderstorm. You never knew, right? You can have lines of thunderstorms. So a line of thunderstorms at least 60 miles long. What does that sound like? What did we talk about earlier that is a line of thunderstorms, like the 300?
The squall line?
A squall line, yeah. So a squall line would also be included in a convective segment. We good? We good. Oh yes, they suggest you stay in bed. All right, lastly, this one, just write a couple notes on. You don't really need to know about this. This is outdated information that old DPEs, I won't give it up, still want you to know, okay? So, area forecasts. It includes observational data, forecasts, and warnings that can be viewed from 14 hours in the past to 15 hours in the future, all right? They include things like thunderstorms and things like that, right? This has since been replaced. We don't look at area forecasts anymore. It has been replaced. But some DPEs just want you to know it used to be a thing, okay? You could find it on aviationweather.gov, aviationweather.gov. In fact, every type of forecast or observation we talked about today, it can all be found on aviationweather.gov, okay? When they ask if you got your weather from an official source, your first answer better not be ForeFlight. You're gonna say, I got my weather from aviationweather.gov, or I got my information from 1-800-WX-BRIEF. Those are the two most legit. And then you're gonna say, my backup, I use ForeFlight. Joshua.
I thought ForeFlight was considered an official legally.
Good luck explaining that to a DPE. You say that exact sentence, you see what happens. You let them decide what is legit or not. Okay? So your first answer, I'm gonna say it again for Joshua because apparently didn't hear. Your first answer is aviationweather.gov. Your second answer is 1-800-WX-BRIEF. And then you say, and as my backup, ForeFlight. You got it? Cool. Cool. Nicole.
One more time. Aviationweather.gov, and what was the second one?
1-800-WX-BRIEF. It's both the phone number you call and it's a website. It's the exact same people who run the flight service stations.
Breeze or brief?
1-800-WX-BRIEF. Did they say their website name? Well, it's written right here, 1-800-WX-BRIEF. It's both the phone number and their website. All right. Da-da-da, da-da-da. All right. Questions from today. Like I said, did this cover absolutely everything on weather? No. But did we give you all the basics so you can build on that? Yes, that's what we try to do today. Joshua.
You said area forecast has now been replaced with the graphical area forecast tool. Is that correct?
Let's take a look. I think they still have an old link for it. Oh, back to normal Zoom. Because they recently changed this website again. Higher up winds, tools. They don't have it anymore. Everyone now just looks at the prog chart, as far as I know. Let's look at the prog chart. From there, you get your weather. Ooh, there's a whole bunch of stationary fronts going on right now. Look at that. High pressure system, there's a trough. Is this storming right now? It looks like it should be. Thank goodness. Yeah. Aviationweather.gov. All the things. The clouds. Oh, another great website you guys should know about. Windy. Is this an official source? Absolutely not. But for every day looking up the weather and seeing what it's like in your area, absolutely fabulous. If you look for like rain and thunder, great. If you're looking for your clouds and you want like just the low clouds, another great source. Windy is great. Is it official? No, but for like situational awareness, yes. Another video I want you guys to have, it's a link. Do. Alexander, I'm almost with you. Give me 1 second, okay?
What causes?
So I did not have a very good instructor when I started, and I wasn't smart enough to ask for a different one. So I do a lot of learning on my own. When I wanted to learn weather, I watched this YouTube video like 30 times. It really helped. Alexander.
Kind of rewinding a little bit. So I've seen on a couple of the practice questions talks about the term outlook. Can you tell me the difference between forecast and outlook?
Well, forecast versus outlook. Forecast is also a verb. Outlook is a useful word in this area. It means the likely future situation. I use them interchangeably, but apparently there might be a minor difference.
Yeah.
Wait, Carson.
While studying, I've come across a couple questions that reference the weather depiction chart, and I've struggled with trying to figure out how to read those.
All right, let's go through it. Do. Oh my gosh, I hate these. All right. Do. Need a better picture. When you're taking your par, there will be a legend at the very bottom. Okay? There should be a little legend that tells you what each one of these things is. That's how I got through the knowledge test. You will only have to actually look at these for the written exam, never in real life. All right. Ooh, that's a good question. Alexander, you're looking talking about Outlook briefings? That is different.
Yeah, I just saw a question and I noticed I got it wrong if I put forecast instead of outlook. So I was curious about that.
Okay. So Outlook briefing, if you're talking to a weather briefer, is the one you're looking for that if your flight is over 6 hours in the future. Joshua, what's up?
Oh, back to the whole that chart you just talked about that we'll only use for our private knowledge exams. There have been a couple questions where it asks about like where does the front that extends to the Michigan Peninsula and through something else, like what is that? I assume we're gonna need to know like the general area of states in the United States, because I'm gonna be honest, I had no idea where Michigan was the first time I saw that.
Yeah, I memorized those answers. I saw the question and memorized the answer. Straight up, because I'm also very bad at geography. Make sure he's hitting the second thing I said, not the first one. Good. Austin, Nicholas, Molly, O'Keefe, you're good. Nicolay, DJ, Blake, Nicole, Corey, Dominica. That one's good. All right. He didn't come. Anthony, Corey, Dominica. Good. Now just Corey. Andy, what's up?
So you covered the NextRad and the TAF when I was dealing with my weird audio issues. Did you define what those were? And if you did, could you like repeat it for me real quick?
So NextRad is like a weather or like a precipitation and thunderstorm viewer that you're going to see in either for flight or in your actual aircraft. In your aircraft, you have your own NextRad system. It's going to show up as like green for like just precipitation and turning like yellow and red for thunderstorms. Is an awesome situational tool to have. However, it can be delayed up to 8 minutes. So you're going to use it for situational awareness, but if you're trying to actually avoid a thunderstorm, it's outdated information.
Okay. And then for TAF, is it much different?
So the TAF is relatable to the METAR in the fact that it's going to be centered at a field. However, the TAF only goes out by 5 miles. Okay, and it's usually good for 24 hours. It can go up to 36.
Okay, cool. And then one more question. Probably a dumb question, but I am having so much trouble defining MSL. Like, I can't figure out what MSL means.
MSL, above sea level.
Above sea level. Okay. And what's the difference? Like, what do we use MSL versus AGL for?
Like when you're flying,
Like, I know
you're
it's
actually
different.
looking at MSL.
Okay. Okay, thank
Oh,
you.
and all of those when we're looking at classes of air, like class Alpha, Bravo, Charlie, and all that, when it's reporting there is also MSL.
Okay. All right, thank you.
Yep. All right, Keith.
MSL is mean sea level, right?
Yep, that is the breakdown. Alrighty, guys, you're more than welcome to hang out. But if you want to go and enjoy your day, go look outside, look at a cloud, you little hippie, then go for it.
I have one last question.
Bring it on.
So winds and temperatures aloft are the only one where the altitude is reported at MSL, right?
If you're talking, the only thing that is AGL is the clouds. Clouds are AGL. Kayla.
I have an unrelated question, but when I was doing some of the practice questions last night, there was a question about if you're on a taxiway and you're getting ready to cross over to a runway, and the sign, it was like a red sign and it said 4-22. And it says if you take a left, where would you be? So in my head, the 4 on the left, take a left, you don't 4, but the test said that it was actually 22. Was it worded wrong or am I just confused?
All right, so you're saying that you're on a taxiway about to turn on a runway and it says 4-22, right? All right. And you said if you, which I didn't understand, when you said if you turn left, you're on what runway? 4-22.
So if this is the sign.
Okay.
And so it was saying if you take a left, I would think you would be on 4 because 4 is on the left-hand side of the sign and 22 is on the right-hand side of the sign.
No. It's saying that if you turn left, 22 is behind you and you're taking off on 22. So when it says 4-22, the beginning of 4 is to your left and your beginning of 22 is to your right.
Okay, perfect. Thank you.
Yep. Keith.
I think I remember that same question. I think you also have to look at the direction, the north, south, east, and west that corresponds with that question as well.
Thank you.